This is an electric pen tester. If you work as an electrician or an electrical engineer, it probably looks very familiar to you. You use it to check if a conductor has voltage, and based on that, you decide if it's safe to work or not. You might even use it as a regular screwdriver. But what you don't know is, this tiny tool might not give you the right sense of safety, but instead, it can actually put you in danger. An electric pen tester is actually a very simple device. It consists of a metal tip connected to a neon lamp, then a resistor, then a spring, and finally a metal contact that touches your finger. When you use it, you are not just testing the wire, you are completing an electrical circuit. The voltage source goes through the resistor, lights the neon lamp, then passes through your body and finally reaches the ground. Yes, your body is part of the circuit. A very small current flows through this path, just enough to light the lamp, but usually too small to harm you. That's why it feels safe. But here's the catch. Your body resistance is not constant. It can change depending on moisture, shoes, floor type, and environment. And in some conditions, it can drop enough to allow a higher current to pass through your body, which means the same tool that felt safe can suddenly become dangerous. Another serious risk is voltage level. Most pen testers are rated for around 600 volts, maybe up to 1000 volts in the best cases. But what if you accidentally use it on a higher voltage line? 6,000 volts, 11,000 volts, or even more. At that point, this is no longer a simple test. It's a life-threatening mistake, because the tool was never designed for that level of energy. There's another hidden problem with that tool, especially in maintenance work. Imagine checking a system that should have 220 volts. You use the tester. It lights up, so you assume everything is fine. You go ahead checking the rest of the system. You spend hours or even days. No solutions. Everything looks fine, but it is actually not. But in reality, the voltage is not full 220 volts, but only 130 volts. The tester doesn't tell you the value, it just tells you there is voltage. So you move on, wasting hours troubleshooting, while the real problem was right there from the beginning. If a multimeter was used instead, the issue would be discovered instantly. If you found this video helpful, don't forget to like and subscribe for more engineering and science content. Stay safe, and thanks for watching.